Okay, so we're going to go over trig identities, okay? They've given us this question here. They want to just prove that this is true, that sine squared theta divided by 1 minus cos theta is equal to 1 plus cos theta. One of the things you try to do with trig identities, it's try to, if you can, get all of your trig terms to be in the same form. So I have 2 cos here, and I have 1 sine. So I'm going to quickly think of some of my rules. How can I replace sine squared theta with something that involves cos? Well, there's a rule I remember that sine squared theta plus cos squared theta equals 1, right? Well, let's set this equal to sine. Well, that means sine squared theta is equal to 1 minus cos squared theta, right? Yeah. So in other words, what I can do is I can replace sine squared theta with 1 minus cos squared theta. So let's do that and see if that helps us at all. 1 minus cos squared theta, and they've written it a little different than we have, over 1 minus cos theta is equal to 1 plus cos theta. Okay, so I'm looking at this. Kind of tough to where to go. It looks like, right off the bat, oh, maybe these two cancel out, but they don't because this thing here is squared, right? Now, there's an old rule in factoring I know about. This is really hard to comprehend. So sometimes, to make questions a little simpler for me, now that I have it all as cos, let's just do something like this. Let's just say, let cos theta equal x. So I'm just going to rewrite everything as x, and maybe that'll help make a question clearer to me. So now what was going to happen is I'm going to have 1 minus x squared over 1 minus x is equal to 1 plus x, right? Now, when I do this, be aware, I'm losing my ability to use my trig identity rules. Yeah. So this might not be helpful. But in terms of factoring, sometimes it's a lot easier to see a solution if I do have to factor the question. So I've done this, and maybe this isn't helpful, and I might have to go back. But now that I look at this, this looks very similar to something I know about factoring. A difference of something.
Squares.
Difference of squares. That is exactly a difference of squares. So, in other words, if I find the square root of 1, which is 1, and the square root of x, I can add and subtract those two values. That's the factor of this here. Okay? So let's try this now. Well, now that's going to give me 1 plus x and 1 minus x divided by 1 minus x, which is equal to 1 plus x. Okay? All right. Well, look at that. I can now do boom, boom.
But what about trig identities?
Okay, before you do that, then you're right. Let's say, let's go back. Remember our trig identity said cos is equal to x, so let's change it back now. X is now back equal to cos. So before I eliminate those, so, okay, I'm just going to rewrite it again. Let's rewrite them as cos. Well, now this becomes our x is now cos theta, so 1 plus cos theta, 1 minus cos theta, okay, divided by 1 minus cos theta is equal to 1 plus cos theta. Does this make sense?
Yeah, but so you can do that?
I can do that to simplify something. Now, I didn't change the question, but remember, what it did do is, because there are a lot of trig identity rules, once I change it into a form of a variable, I lose all those rules. I can't apply them because it becomes very hard to comprehend such an idea. So just quickly to show here, okay, we know those two cancel out, and lo and behold, well, 1 plus cos theta equals 1 plus cos theta.
Yeah.
Okay, we got it. Now, that might not always work. But in a question where we might have to factor something, that might be helpful. Now, the reason I did it for you guys is I personally could see that this was a difference of squares, but I wasn't sure if you'd be able to see that as a trig identity. Yeah. That's why I replaced it as an x, so it looked a little more familiar to you. But you have to start to think of that as cos theta is almost like some variable we don't know about.
So you can factor a lot?
Yeah, you can factor trig identities too using the old factoring rules we know. Okay, so just kind of keep those in mind as you go through them.